Hello everyone, in this video we will learn about database management system. So for learning database management system, you should know what is meant by data and what is meant by database. So we will see what is a data. Data can be facts related to any object in considerations. For example, your name, age, height, weight, extra, some of the data related to you. So what is meant by database? Database is a systematic collection of data. So they support electronic storage and manipulation of data. So this databases makes the data management easy. So now we can define what is meant by database management system, or in short we call it as DBMS. Database management systems are software systems used to manage and manipulate data in a database. So it consists of information about a particular enterprise or organization. So in a database you will be having collection of interrelated data, then set of programs to access the data, and an environment that is both convenient and efficient to use. So this is the database. So we'll be having some application program, then here this is the end user. So here the end user part, this is an environment that is both efficient and convenient to use. Then here the application program is to access the data. So here we'll be having the data. So what are the functions of DBMS? So the basic functions of DBMS, the main function is for the management of data. Then it can be used to define the structure of how the data can be stored. So also it can be provide mechanisms for the manipulation of data. Also this DBMS ensures safety of data. In case of system crashes, the data won't be tampered, or the data will be safe. And it also ensures that unauthorized access is not there and the data is not misused. Then also the concurrent control in multi-user environment is possible by means of this DBMS. So why we need a database? Because we can retrieve information very easily in a database. Also, if you use database, the redundancy can be reduced, inconsistency can be avoided. Also, the data can be shared, various standards can be enforced into the data. Also, the security restrictions can be applied into the data. The integrity of the data can be maintained. Then also it provides the data independence. Now, as I said, the database, we can it can be viewed by a lot of different people, because it stores the data of interrelated things. So, for example, in an organization, various employees will be there, which will be having various portfolios or the designation. So, each person will be requiring a different data. It may not be the same data to be accessed. So, this database provides different data according to the user requirements. So for example, you may be having a payroll officer which needs to access staff details, or it can be customer service advisor which needs access to customer accounts. Sales manager needs access to stock level. So the DBMS will be providing only those particular data according to the user requirement. So what are the characteristics of DBMS? We know that it is a digital repository which is established over a server to store and manage the information. Also, it can provide clear and logical view of the process that manipulates the data. It contains automatic backup and recovery procedures, and the properties, it contains ACID properties, that is atomicity, consistency, isolation and durability, which is very much required to maintain data in a healthy state in case of system failure. Also, it can reduce complex relationship between the data. It can be used to support manipulation and processing of data, and also to provide security of data. Also, it can view the database from different viewpoints according to the requirement of the user. That is, a particular user may be requiring a particular data. So, it may be like the remaining data will be hidden from that particular user. So, whatever data is required by that particular user will be provided to that one. So, DBMS can provide various different viewpoints according to the requirement of the user. Who are the users of DBMS environment? So we have in DBMS the users as application programmers, then we have database administrators, we have end users. So what is the purpose of this application programmers? So application programmers, they write the programs in various programming languages to interact with the databases. What is the purpose of database administrator? They are responsible for managing the entire database system. So they are called as database admin, or in short they will be called as DBA. End users are we people like end users are the people who interact with the database management system. So they conduct various operations. The users may be conducting various operations like retrieving or updating, deleting, etc. So these are the various users which in a DBMS environment. So here we can see that visitor, they will be here. This is the DBMS, the data is there here, and the visitor or the user will be accessing the DBMS through a programming language, for example SQL statements. So now here in this particular this one is a database system environment. In this you can see the end users and the programmers, then database designer, database administrator, system administrator and all. So here we have the database management system. So data is stored here. Then this one is the designer who will be designing the database design, then the database administrator who manages the database, and the programmers write application programs. So why they write the application program? So as the end users to access this DBMS, the data from which is stored in the database management system. So this is the basically a database system environment works like this. Now, what are the popular DBMS software which has been used? Some of the common or the popular softwares which are in use is MySQL, then Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, Microsoft SQL Server. These are some of the commonly used DBMS software. Then what are the applications of DBMS? DBMS find applications in every field of life. You can see that the applications in banking, airlines, universities, telecommunication, finance. So in banking, this DBMS can be used for customer information, account activities, payment, deposit, loans, etc. It can be used in airlines for reservations and schedule information. Then universities for student or the faculty informations, course registration, colleges and grades. Then it can be used in telecommunication field to keep call records, monthly bills, maintaining balances, etc. Then also DBMS can be used in finance field for storing information about stocks, sales and purchases of finance instruments like stocks and bonds. Also it can be used in sales, manufacturing, online retailers, human resources management. In sales it can be used for storing customer information, products and sales information. Then online retailers, as you know now, the online most of the people depend upon online purchases. So online retailers, they use this DBMS for order tracking, customized recommendations, etc. And also it can be used in manufacturing field. It is used for management of supply chain and for tracking production of items, inventory, status in warehouses, etc. Then also it can be used in human resources management for information of employees, payroll, tax deductions, generation of paychecks, etc. Then coming on to the DBMS architecture, generally we have a one-tier architecture, two-tier architecture and three-tier architecture. The most commonly used architecture is of two-tier and three-tier. Here we can see a three-tier architecture in which we can see there are three levels of abstraction. You can see here there is an external schema. Then we have external schema, then conceptual schema, internal schema, like that. So this external schema is the highest level, and the lowest level is this internal schema. Internal schema is otherwise called as physical level. So the data abstraction in this physical level is at the lowest level. So this level describes how the data is actually stored in the physical memory. So the physical memory may be hard disk, magnetic tapes, etc. And so in physical level, the methods like hashing are used for organizing purpose. So developer who know the requirement size and accessing frequency of the records clearly in this level, which makes easy for designing this level. Then comes the conceptual level. Conceptual schema is otherwise called as a logical level. So this is the next higher level of abstraction. Here, this level is used to describe what data the database stores and what relationship exists in between the data items. So the logical level thus describes an entire database in terms of a small number of relatively simple structures. So next level is that is the highest level, that is the external schema. External schema is also called as view level. So this is the highest level in which the user interaction happens at this level. So the level describes the user interaction with the database system. So in this in the logical level, simple structures are used, but still complexity remains, because in the large database various types of information are stored. So here many users won't be aware about what is there inside this, the complete details of the system. Also, they need not access the whole information from the database. So here, so it is necessary to provide a simple and short interface for such users to get their requirements. So multiple views also can be created for the same database for multiple users. So this is the basic structure of a DBMS architecture. Then coming on to the types of DBMS database model, we have various models. Hierarchical data model is there, network data model is there, ER data model is there, relational data model is there, and object-oriented data model is there. So what is a hierarchical data model? Hierarchical database, it is in this the model is the data is organized in a tree-like structure. So here you can see that it is a hierarchy. There is a stored hierarchy. So data is stored in a hierarchical manner. It can be top down or bottom up for a format. So here the data is represented using a parent-child relationship. So here the parent may have many children, but the children can have only one parent. So here this is an example in which college has the children as department and infrastructure. Then the department is again have course, teachers, students, then theory, labs. Course is divided into theory and lab. So this is a hierarchical structure. So you can see there is a tree structure is formed in this hierarchical DBMS. Next comes the network model database. So in this one, the data is arranged in the form of a graph. So here all the entities are organized in a graph which can be accessed through several paths. So these are all entities, we can access it through several paths, and here we can see that each child can have multiple parents also. See here, this one C2 can have this B1 and B2 are the parents, so each child can have multiple parents. So in this models, as I said, it is organized in a graph. So this is most widely used database model before the relational model was introduced. So we will see what is the relational model. So relational database is the most widely used database management system model because it is one of the easiest one, because we arrange the data in the form of tables. So it is based on normalizing the data in rows and columns of the table. So the basic structure the data stored is in the form of tables. So you can have rows and columns. So the attributes we will be storing in the columns, and these rows are called tuples. Basically this tables are called relation because it is a relational model. The tables are otherwise called as relations. So here the relational model stored is it is in a fixed structure, and we can manipulate this relational model by means of SQL. And next comes the object-oriented model. So here the data is stored in the form of objects. So here we can see that the structure which is called classes which display data within it. So we can see that the database is a collection of objects which stores both the data, member values, and operations also. This is an object-oriented model. Next comes the entity relational model, or in short we call it as ER model. So this is basically a high-level data model. And this is used to define data elements and relationships for a specified system. So basically ER model is represented by portrayed as a diagram called as ER diagram, and this develops a conceptual design for the database. So this is very easy and simple to design view of data. So basically this model consists of entities and their attributes, so and also the relationship among the entities. So in the ER diagram we can find entities, attributes, and the relationship among them. So what is meant by entity and attribute, which we use in this ER model, that is entity relational model. Entity is something which is, it can be a person, place, or even a concept. Attribute are properties associated with an entity, that is called an attribute. So every attribute is defined by its sets of values called domain. For example, we can we can take student as an entity or the teacher as an entity, and the properties associated with the students can be called as attribute, or the properties associated with the teachers called as attribute. So the properties associated with an entity is called attribute. Now for a student, I can have the student name or the roll number or the ID, date of birth, all can be the attribute of the entity student. For teacher also, teacher can be having name, then teacher ID, all those things can be, or the qualification, all becomes the attribute of the entity teacher. So now for every attribute, there is defined by a set of its values called as a domain. For example, roll number, when I am talking about, it can take only numerical values. So it will be the domain which this is belonging to, that is defined. The set of values that particular attribute can take is defined as domain. So it won't be taking alphabets, it will be taking only numerical values. So for example, for roll number, it will be taking numerical values. So similarly, other attributes will be having its own set of values, which is called as the domain. So every attribute will be having a domain. Then we have the relationship. The logical association among entities is called relationship. And that is meant by, for example, if you have an entity student, we have another entity teacher, and this student and teacher are related by logical association, which is called as relationship. So the teacher teaches student, so teachers becomes the relationship. So the relationship is the logical association among entities. So we can actually map this relationships with entities in various ways. So how many this mapping from one entity to another, it can be one to one, or one to many, or many to one, or many to many. So this is an example for an ER diagram. So here this rectangular boxes represents the entities, and the oval represents the attributes, and this diamond represents the relationship among the entities. For example, if this entity is student and this entity is teacher, and the relationship among the student and teacher, I can represent it with this diamond. The teacher teaches the student, or the teachers becomes the relationship. So attribute associated with the students, for example, name, roll number, all can be attributes of the student. Similarly, the attributes for teacher also will be there. So this is how we will be representing an ER model. Next, coming on to this SQL. SQL can be pronounced as SQL, or it can be SQL. It can be pronounced as SQL. So it is a standard language for storing, manipulating, and retrieving data in databases. The full form for SQL is structured query language. So what is the purpose of this SQL? We know that data is stored in a DBMS, and to access or to manipulate the data, we need some programming language. So for that we use SQL. So I will be covering this SQL. I'll be detailing about the SQL in my next video. So I hope the understanding of the database management system is clear, the fundamentals or the introduction. So what is meant by data, database, and what is the purpose of the database, and how you can access the database, that is by means of a programming language. So for that we will be discussing about that in my next video. So for getting updates about the future videos, please subscribe, and if you like the video, please like the video and subscribe. Thanks for watching. Thank you.